My name is Andre Loico.
My name is Angel Quintana.
My name is Steven Sanchez, and this is our boat trip project on corrosion's ability to damage. Our project focuses on us gaining an understanding of corrosion and its effects on the industry. We chose this topic because we are located in the Galveston area next to the ocean. This also ties into our lecture and Kev Lab experiments on corrosion and its effects in the industry.
Corrosion in particular was analyzed with respect to the maritime industry of Galveston due to its ability to damage maritime environments and human equipment. This is shown in this diagram above, where salt and moisture, a catalyst for corrosion, is able to negatively impact coastal power supplies and electrical engineered power systems.
But how is corrosion tied to chemistry? Well, chemistry is closely tied to corrosion, from how elements interact to form rust to how the environment accelerates the process through saltwater transferring electrons. And the duties of the trio. I was a team facilitator because of my organizational skills, which included the meetings, submissions, and drives conversations.
I was a product and team manager, meaning that I was just double checking the quality, the content's quality was adequate.
My role was this research facilitator, and I was chosen because of my collaboration skills. My job was to ensure that we were on task and doing our job effectively. Some challenges we overcame were scheduling discrepancies. I was involved in GSO and was gone every Thursday, so we could not meet at that time. We also had schedule differences that wouldn't allow us to meet at certain times on certain days. Lastly, family obligations. Me and Andre had family obligations on the weekend that we had to attend, which didn't allow us to attend our group meetings on the weekends.
Another challenge we had to overcome was ability to communicate with each other. We primarily communicated with each other through iMessage and group chats. However, due to technical difficulties we are not fully aware of, the messages would not be sent to one another, meaning there was difficulty planning in advance when we were going to meet.
And as a team, we came to the agreement that we would have professional positivity, regular communication, no plagiarism, and the team leader would have the final say on what we submitted. When
we were deciding prior to determining we were going to do corrosion, we were initially interested in our majors of interest. So I was doing electrical engineering. So with respect to the sea industry, I was interested in an integration of electrical engineering structures alongside the ocean.
Mine was more focused on the mechanical engineering side and its materials on corrosion. Some materials corroded more than others, which caused engineers to develop new designs and materials to use.
And my initial proposal was tied to civil engineering, where we would study how civil engineers made structures in water and how we could further reinforce them to resist environmental pressures.
In spite of all of our initial proposals, we determined that corrosion would be the most appropriate option to study due to its broad research that can be used, as well as easier to visually notice and chemically understand what was occurring as to why. Now that we determined we're going to focus on corrosion, we found two locations we were going to analyze to see the impacts of corrosion: the USS Selma and the battleship Texas. The USS Selma is an abandoned World War I ship, and the battleship Texas was an actively maintained ship. The USS Selma is a prime example of how corrosion is able to heavily damage man-made structures through the persistent contact of water. In the top photo, due to the low sea level it is at, there is a concentration of algae due to the pushing of waves alongside excessive corrosion being formed as a result. Due to this algae, there's a heavy presence of pelicans and seagulls. The combination of algae, pelicans, and seagulls results in creating an artificial ecosystem that in of itself damages the environment. However, it also heavily damages the ship. Had this ship been actively running, there would be a lot of problems in having to figure out an appropriate and legal way to get rid of the algae in ships and seagulls. The bottom photo of the USS Selma showcases the full extent that the degradation that a ship can occur due to corrosion. right? There's a clear discrepancy between parts of the ship that are further away from the water, the point of interest, with the persistent contact of water being inevitable. It leads to excessive corrosion, looking like it was dipped in battery acid, right? So the photo showcases the true extent that corrosion can damage a ship, leading to being very expensive, having to continuously repair the ship.
The picture above is a side view of the SS Selma. The ship is stationed at an angle and is exposed to excessive water on more excessive water on one side, which creates a harmful metallic paste that is harmful to both ocean and land. This is a form of corrosion called pitting corrosion, which focuses more on one point due to its exposure. The ship highlights the importance of corrosion and corrosion prevention techniques, as well as the economic and safety consequences it brings.
The battleship Texas is a prime example on how corrosion treatments can further increase the lifespan on ships. The photo shown here is after extensive reconstruction when it was deployed a century ago. Extensive treatments were employed by coating the hull of the ship in reactive metals like zinc, which increased its lifespan and allowed it for its frame to be strong enough to be continually repaired and for more treatments to be reapplied. And how does corrosion affect ships exactly? Corrosion happens because ships are made of iron, which when in contact with oxygen form rust. The water in the ocean has a lot of oxygen diffused in it, which then triggers the chemical reaction, as shown here. Then when rust forms, it's extremely brittle and falls off due to the formation of waves, which then creates stress points, and then these stress points then cause rust to form even more quickly, which then cause even more stress points, and this then causes the structural integrity of the entire ship to come into the danger zone. And finally, the salt in the ocean also increases the rate of corrosion. This is because salt is a semiconductor that when in a liquid, the water of the ocean, allows for electrons to flow easier from oxygen to iron.
Now that we have developed a chemical understanding of how corrosion occurs, it can then be seen that corrosion is very damaging to structures that utilize metal in particular, like ships. Okay? As well, that corrosion is very damaging to marine environments, particularly through rust contamination. The concept where the formation of rust alongside harmful bacteria damages water as well as wildlife. However, through our research cases, it can then be seen that this is numerically, corrosion is damaging through its intense economic impact, with 90% of ships experiencing failure as a result of corrosion for a 2018 study, with 3% of the United States GDP annually being focused on corrosion mitigation and prevention. As a result, from an engineer's lens, it is seen that corrosion is somewhat inevitable, but it can be mitigated, leading to
the different industries that study corrosion and how to deal with it. Material scientists investigate how external factors will affect metal and metal alloys that go into building ships. Chemists will study the chemical reaction behind corrosion and how more reactive metals can be used to stop the reaction, and how engineers apply their knowledge to create more corrosion resistant structures and implement strategies to control corrosion.
Our ideas to overcome corrosion include cathodic protection, which uses sacrificial metal anodes like magnesium, zinc, and aluminum, which are more prone to corrosion and protect the primary metals such as steel from corroding. Another one being nanotechnology coating, which coats it and prevents corrosion at a molecular level, seen on the picture to the left. An example of this being the battleship of Texas that uses nanotechnology to keep it running and going for a longer amount in periods. Lastly, a simpler way is keeping up to date with the maintenance and changing the metals to prevent further damage.
These are our ideas to overcome corrosion. Thank you for your time.